Hello and welcome to our first video. For this first project, I want to work on something very simple. I want to create an application that's going to grab weather data from the internet and present that data to the user. So let's formalize that idea. So the project we're going to build is the user should be able to provide a city name, and the app should then grab weather data for that city, and then finally present that weather data back to the user. So that really summarizes the idea of what we want to build. And I also want to quickly talk about some of the tools that we're going to need, as well as some of the resources that we will need. In terms of tools, we'll need Python itself, and we will need an editor. So for Python, you can download it from www.python.org. The version that I have installed is Python 3.8, but feel free to download the latest one, which is Python 3.9 as of today. And in terms of the editor, you can download Notepad++. It's a very simple and easy to use tool. It's free. So for this project, it's more than sufficient. For future projects, I will probably switch over to a more complete IDE. The one that I use for my day job and my side projects is Visual Studio Code. But for this video, I want to keep it very simple since this is the first video. So Notepad++ is perfectly fine for this project. So to download Python and Notepad++, you can go over to python.org and download Python. Just head over to the Downloads tab and click Python 3.0 and install it. And then Notepad++, you can download it from notepad++.org/downloads, and just download the latest one. The one that I have is 7.9.1, so feel free to download that one. If you have a different editor that you prefer, then go ahead and use that. But if not, I recommend Notepad++. It's the one that I'm going to be using for this video. If you want to follow along with this video, then I recommend you pause the video, download and install Python and Notepad++, and then come back to this video. Now, in terms of resources, since we want to grab weather data for a city, we're going to need a provider of that data. So we're going to need a weather data provider. So I already have a data provider in mind. I did a bit of research and I found a data provider, but I still want to walk you through the thought process of how one might go about researching and then settling on a particular data provider. So when you're building a project, this is typically one of the things you'll do is think about some of the resources that you need, and then do a bit of research and then settle on a, in our case, a data provider. And I believe I have one more thing I want to talk about. So I want to talk about the Python virtual environment. So we are going to install Python on our computers, but we're not going to be using the system Python. Instead, we'll create what's called a virtual environment. So a virtual environment is essentially an isolated Python environment. And what that means is when you create a virtual environment, that Python installation or that Python environment is separate and isolated from your system Python or the main Python that you have installed on your computer. And what that allows you to do is it allows you to have multiple versions of Python on the same computer, and each version of Python can have its own set of third-party libraries, and this is especially useful if you want to work on multiple projects on your computer. So without a virtual environment, every time you want to switch between your various projects, you'd have to go through a painful process of uninstalling and reinstalling libraries and then having to deal with version conflicts, and that's something that we can avoid entirely with Python virtual environment. So it's generally a good idea to create a virtual environment whenever you're starting a brand new project. On Linux systems, this is a particularly important point because on Linux systems, they typically come with a system Python already installed, and you typically don't want to make changes to the system Python. On Windows, it's less of an issue because Windows doesn't come shipped with a Python already. So, but we still want to make sure that we create a virtual environment whenever we're working on a brand new project. Also, I want to let you know that there is a Python library called Requests, which is what we're going to be using for this project. And Requests is a third-party library for working with HTTP. So if we need to make HTTP requests, your options are either to use the built-in Python HTTP libraries or use a third-party library, something like Requests. Requests is what we're going to use. It's a very popular third-party library, and it's often cited as being an example of a third-party library with excellent, well-engineered Python code. So I recommend that you take a look at the source code whenever you have time. It's really well organized and well engineered, and it is sort of the de facto standard in terms of tooling for HTTP requests within the Python ecosystem. So having said that, I believe we are covered for most of what I want to discuss. So the next step here is to research for a weather data provider. Now, as I mentioned, I already have a weather data provider in mind, but I want to walk you through the thought process. So let's Google for weather data API, and I'll put free in there. So as you can see, there's a bunch of results that come back. There's something called openweathermap.org, which is in fact the one that we're going to be using today. There's rapidapi.com. They have a bunch of weather APIs that we can use, and weatherstack.com. So as you can tell, there's a lot of different services that we could be using, but we're going to be using openweathermap.org. So what I did initially before I recorded this video is I went to openweathermap.org, and then I looked at their documentation and I found current weather data. So current weather data provides us with weather data for over 200,000 cities, and it provides it in various formats like JSON, XML, HTML, and it's available for free and also for paid subscriptions. So I ended up creating an account with openweathermap.org, and so I recommend that you do the same. It's free, as I mentioned. So to create an account, just go over to subscribe, click the subscribe button, and get API key, and just fill out the details here. Feel free to use a dummy email account. My email account here is cached, so I'm going to use that to log in. But feel free to create an account, and once you're done, you'll need to sign in. So I'm going to sign into my account, and then I'm going to go back to the API link, and I'm going to click the API doc link right over here. This page documents how to use the API. So API stands for Application Programming Interface. It's essentially the way that our application can talk to openweathermap.org, and so this is the page that documents how we can communicate and get data from their service. So api.openweathermap.org is the service provider. /data 2.5 weather is the resource that we're going to be using, and we need to pass in a query parameter called Q and provide the city name there, and then an app ID, which is the API key that they provide us with. Now you can grab your API key from, if you go into your account, so on the top right corner of my screen, I just clicked on my username, and then I went to my API keys. I'm going to hit Control click so I can open up a new tab, And on this page, I can see my API key, so I'm going to copy that, and I'm going to just quickly paste it into my notepad here. So I've got my API key, and we can take a quick look here at the documentation. So this tells us that these are the various parameters that we can pass in. So Q for the query is for the city name, state code, and country code divided by comma. So that's what we pass in for Q. And then we need to pass in an app ID. These two fields are required, and everything else is optional. And they also give you some examples of how to call the API. So I believe we have what we need to begin coding. Let me start up my Notepad++. And here I've got my brand new Notepad++ window. I'm just going to make one change to the default. That is, I'm going to go to Settings and Style Configurator, and I'm going to change the default style to Solarized Light. I think that just looks a bit better. It's easier on the eyes. And I'm going to move this over to Notepad++. I'm going to delete this. And there we go. So let's start a brand new project. Now, I mentioned that we're going to be using a Python virtual environment. So let me show you how to do that. I'm going to start a new command prompt window. And this is my home directory. And let me create a new directory for our project. We'll call it weather app. So I'm going to create this weather app directory, go into the directory, and here I'm going to create the Python virtual environment. So I'm going to call Python. So if you just hit Python, you see that the interpreter popped up, and we could tell that I have Python 3.8.3 installed. I'm going to hit Control-Z, Enter to exit the interpreter. And to install the virtual environment, the command is python-m, the venv module, and then the name of my environment. So I'm just going to call it weather app env, and hit enter. And once the virtual environment's created, we can activate it by typing in weather app env/scripts/activate and just run that script. And we know that the environment's activated when we see this prefixed to our prompt. So there's a parentheses and then the name of the virtual environment, so weather _app_env prefixed to the standard prompt. And that tells us that we are in the Python virtual environment that we just created. Now, there are better ways to manage virtual environments. As you can see, this prompt is rather long. There's quite a few characters there. And as we work with more and more projects, switching between various virtual environments can become a little bit tedious. So there are tools out there to help with that, which I'll cover in future videos. But for now, this is our virtual environment and it's been activated. And I mentioned that we're going to be using the requests library. So let's install that. To install it, I'm going to run pip install requests. And this tells us that we have successfully installed requests along with some dependencies. So we have Python, we have the requests third-party library installed, and we are ready to code. So let's start up a new file, and we'll save this file, and we'll call it, well, let's navigate to the home directory. So this PC, So what I'm going to do is I'm going to copy this weather app folder copy, and I'm going to move it over to my documents. I'm just going to paste it here. So we have not only copied over the weather app folder, but we've also copied over the virtual environment. And so you can see how easy it is to move the entire virtual environment around. All right, so now that's been saved. And get rid of this window. And we'll save our file as weather.py. Okay, so we know that we need requests, so I'm going to import requests. And to organize this better, let me split the windows. So I believe we can do this through Edit or View. Moved clone to other view. There we go. So let me save this, close it. I'm going to increase the font, decrease the font for this. There we go. All right, so I'm going to import requests, and I'm going to save our API key as a global variable. And what else do we need? I believe that's all. And for the city, let's just provide a test value in. City name is going to be Toronto. Let's look at the documentation just to make sure that we're passing in the query parameters correctly. So city name, state code, and country code. So Toronto, let's pass in on Ontario for the province, and country code would be CA for Canada. All right, so we are gonna convert that to dynamic values, well, the city name, because we want the user to pass that in. But for now, just for a quick test to make sure that we are able to talk to the API, I have hard-coded these values. So API key, city name, and we also need to know the service itself. So this is the API. Let me save that here. So the API host, and we'll prefix it with HTTPS, just to make sure that we are sending data securely. And then the resource is that. So the weather endpoint, and that's about all we need. Okay, so let's make a request to the endpoint. So to make a request to the endpoint, we can use the requests.get method, and the get method accepts some parameters. So the first parameter is going to be the URL that we want to make the request to. So let's construct the URL. So the URL is the API host, and the weather endpoint. Yep, so that's the URL. And the reason I split up the API host and the weather endpoint is because in the future we may want to add additional endpoints. So to do that, we would simply just add another endpoint, and then we can concatenate the string again without having to change the API host. So let's pass in the URL. And we also need to pass in some parameters. So the parameters, the params parameter accepts a dictionary. So let's build the dictionary. So our params is going to contain the Q param, and the value for that is going to be our city name, as well as the API. I'm going to have to reference the documentation, the app ID, and that's going to be the API key. So if you remember, when we looked at the documentation, we found that there are two required parameters, the queue parameter and the app ID parameter. They're both required. So for the queue parameter, we passed in a string, which is the city name, state code, and country code divided by comma. And the app ID is the unique API key. So we've done just that. We passed in queue, we've passed in the app ID, and now we're going to pass that into params. So this will give us back a response object, which I'm going to save to the R variable, and then we can print out the status code. So we can say the request status, and let's print out the status code of the response. Now to run this, I'm going to simply type in Python. Well, let me clear my screen. And I'm going to type in Python. Excuse me. We changed the directory, or we copied the folder to a different directory, so I'm going to navigate there. So it was documents, and then weather app, and weather.py. So Python space weather.py, enter. And the response is a 200 HTTP 200 code. So the HTTP 200 code tells us that the request was successful, and we can then proceed to try to look at the response. So let's look at the JSON that the service provided us. And we can see that the response is a chunk of JSON with a lot of data in there. So I think you'll agree with me that this is a little difficult to read because it's all scrunched together. Now, we can make this a whole lot easier to read by simply formatting it a bit better. So to do that, we can use the built-in JSON library, and instead of printing out JSON, simply JSON, I'm going to pass this into the JSON library, which has a dump_s method. So we want to dump this JSON as a string, and I want to indent it by 4 characters. So if this is not very readable, we have essentially done this. The formatted response is json.dump_s, the JSON that we got back, indented by 4 spaces, and that is what we're printing out. So let's go ahead and try to run that. And as you can see, it's a whole lot more readable. So let's take a look at the response. So the response contains a lot of useful data. So it contains the coordinates, longitude and latitude, the weather information, so it tells us that currently there are overcast clouds, and it also tells us the temperature. So these are clearly not Fahrenheit or Celsius, so we'll need to learn how to convert that to either Celsius or Fahrenheit. Gives us some visibility. We don't know what measurement of unit that is, but we can research that and find out. There's information about wind, and of course the country, which is Canada, and then sunrise and sunset time, and the name of the city. So this is a successful response. We've got the data that we need. Now let's print out just the temperature. So we know that the response provided a JSON with a key called main. which the value of which is a dictionary, and the dictionary has this data in there. So it looks like the value that we want to look for is this temp with the value of 275.46. So let's grab that out of the dictionary. So the temperature is r.json, and the key is main, and then the inner dictionary's key is temp. So let's print that variable out. And we can see that the temperature is 275.46. Now the next step is we need to figure out what unit of measurement this is, so that we can then convert that to either Celsius or Fahrenheit. So going back to their documentation, let's see if we can find that out. Okay, I see here, units of measurement. So units of measurement, standard, metric, and imperial units are available. Okay, so these are specified through the parameters. So let's look at the parameters for the endpoint that we used. So units. All right, it's an optional parameter, but if we provide the units parameter, then we should be able to get the measurement that we want. So we can either provide standard, metric, or imperial, and by default it returns standard units back. So let's go ahead and supply a unit of metric. So I'm going to format this so it's a bit easier to read. So we're going to supply in unit, and the value is metric. And then let's try again. Okay, so that looks a lot better, 2.31. So believe that that is Celsius. Let's verify that by Googling Toronto, Canada weather. So it's 37 Fahrenheit, and then if I switch to Celsius, it's 3 degrees. So that's close enough. The Google weather probably is a little less accurate than the data that we got back. But we can see that the application is doing essentially what we want it to do. So now that we have this basic piece of code working, let's organize it a bit better. The first thing that we can do is we can group some of the similar like logic into a function. So let's create a function called main, and we'll put everything inside main. And then if we run this code, it's going to return nothing back, because although we've created a main function and we have the logic within the main function, we're not actually calling main. So let's call main. And as you can tell, this is the same response that we got back initially, so we know that this is working. Now, what we just did is called refactoring. And refactoring is something that you should be doing all the time. It's the process of essentially improving your code and reformatting it. You typically want to combine refactoring with unit tests. So in future videos, I'm going to show you how to work with the discipline of what's called TDD. So TDD stands for test-driven development. The idea being we first write tests, the tests which drive the development of whatever code that we're writing. That ensures that, if you follow the discipline, that every piece of code that you write will be well tested, and then refactoring becomes much safer, much easier, and generally programming becomes much more fun. So for future videos, I'm gonna use TDD to build all our code, all our projects. But for this video, we're just going to manually test after each major change. So we know that the main function works. Now, one of the initial requirements was that we want the user to be able to provide a name of a city. If you look here, we have the city name hard-coded, so the user can't really provide any value really. So we want to make this dynamic. We want the user to be able to supply a city name and then have the program process the weather data for that city. So how might we do that? Now there are a bunch of ways to do it. The simplest way is going to be to capture parameters on the command line. What I mean by that is the user should be able to type in python space weather.py space something like this, Toronto. And with this command, the user should then get back the weather for Toronto. And if the user were to supply in some other city name, like New York City, and so on, they should then get the temperature for that city. So how do we do this? We can do this by using a Python built-in library to handle arguments on the command line. Now let's research this. So I'm just going to type in Python command line arguments, and one of the first, oh look at that, this is something new from Google. Curious developers are known to seek interesting problems. Solve one from Google. Not for today, but I'm definitely gonna check it out later. So you can tell that there are a bunch of results here, but the one that I'm interested in is the official documentation. Official documentation for Python is great, and sometimes it can be a bit cryptic, but it's a really good skill to learn to be able to understand the official documentation. So let's try to look at the Python official documentation for argparse. All right, so argparse is a parser for command line options for arguments and subcommands. So let's take a quick look here. Now, here's an argument, or here's an example rather. The way to use it is you import argparse, and then you provide a description for your application, and then you can add arguments. So it's got a really nice interface. For numbers, you would pass in integers. So for numbers, you would type in a type called int, type with a value of int, and then this is the argument itself, integers. And an optional way of providing an argument is using the dash dash and then the name of your argument. And then you can store that to a variable. Yeah, so it looks pretty interesting. Looks like this is something that we want. So assuming the Python code above is saved to a file called prog.py, it can be run at the command line and provides useful help messages. So we get a help message, which is constructed dynamically based on the arguments that we define. And so if someone were to type in, if a user were to type in Python, and then our application is called weather.py, so Python weather.py -h, they would then get this really helpful help menu back. So let's try that. So I'm going to open up our weather.py file, and we're going to import argparse. And I am then going to, let me split this to the right so that we can read the documentation at the same time. So what we want to do is we want to create a new variable called parser. equals argparse dot argument parser, and we'll provide a description. What should we call this? Weather application. So there's our parser instance, and we're going to add in an argument. So parser dot add argument, and we're going to, I like the dash dash sum, or the dash dash style better, so I'm going to use that. So dash dash city, and then we'll save it to, so I don't know what dest or what dest does. So let's look at the documentation further. Okay, so by default, argument parser, hang on, let me just organize this better. There we go. So by default, argument parser objects use sysc.argv0 to determine how to display the name of the program in help messages. Okay, so usage. Description. Formatter. Okay, so what I want to know is, I want to know what dest does. Okay, dest. The name of the attribute to be added to the object returned by parseargs. Okay, so that sounds like it means that the accumulate variable here in this example is where the argument gets stored. So let's pass that in. Dest equals city. So if we call city, that should give us the whatever city that the user provided. And we could also provide a help string. Now I'm going to define what that help is going to be. So help is provide city name with format, and I'm going to specify the format based on the API documentation, which is city name, state code, country code divided by comma. Use ISO 3166 country code. So I'm just going to copy that and paste it here. Now, this is a really long string. If I go to the end of this string, I can tell that this is 125 characters long. So I'm going to make this a bit more readable. And I'm going to use what's called implicit line continuation. So let me just make this smaller for just a brief moment here, because the goal is I don't want each individual line to exceed more than 80 characters, because that will then make it readable for people working with restricted windows, and especially it's useful for development when you have multiple window panes like what we have here. We've got a left window panel and then a right panel. So if you have multiple panels like this open, and then you have some really long string, it becomes difficult to read the code and understand what's going on. So limiting that to 80 characters just helps with the organization. So I'm going to provide the city name with the format, and I'm going to look for about 80 characters. So right about there, and I'm looking at the call 79 over here at the bottom of the screen to tell how many characters that is. So I'm just going to end that with a quote, and then go to the next line, start a new quote, and then close that off. So this looks like a Python tuple, but notice that there aren't any commas here. If I added a comma like this, then this would be a Python tuple, specifically a Python 2 tuple with 2 elements in there. But if you have a string, a multi-line string, enclosed with these ellipses, and there aren't any commas separating these strings, then by default Python will concatenate them as one long string. So here we have our help message. I'm going to copy this and save it here. So it should display this bit of string here. And then going back to the argparse documentation, we can then use this here. So args equals parser.parseArgs, and args should now contain a attribute called city because we've saved that as the destination variable. So let's try that out. What is args.city? And then we'll print args.city and run the code. So args.city is none. You probably didn't catch that, but if I scroll up, we can see that args.city is none because we didn't really provide anything here. So let's provide a value in there. So python space weather.py space, let's pass in Toronto, Ontario, Canada. Okay, so unrecognizable or unrecognized arguments, Toronto, Ontario, CA. All right, let's just pass in Toronto and see what happens. That doesn't work either. That's because we need to provide the argument as --city. So actually, let's pass in -h because the argparse documentation tells us that it comes with this really helpful -h argument, which if we run should return us a help menu. So let's try it. And we see this really useful help menu. So it gives us a usage. So call weather.py and provide these valid parameters, either -h or --city. And --city has a description of what value it accepts, which is the string that we saved earlier in the help variable. Great, so we now know how to pass in the city. So let's pass in city equals Toronto, Ontario, CA. Now if we scroll back up, we can tell that the city is Toronto, Ontario, CA. Let's go back and refactor our code. So in the code, let us then pass in the argument to main. So we'll pass in or rather we can just pass in the argument right here. So city name, we'll pass in args.city and save. And I'm going to delete this line because we don't need to debug that anymore. We know what args is. And let's go ahead and run the code. So no surprise, we got the weather data back for Toronto. Now let's try a different city. So instead of Toronto, let's try New York City. So New York, and then this state would be New York, I believe, and the country code USA, or just US, and try that. Okay, so unrecognized arguments. So we can see that there's a problem here with the parsing. When we passed in dash dash city equals, it stopped parsing right after new, and everything after new, which is York, comma, the state, and then the country code, was ignored. Now that's because of this space. So let's try to wrap this in quotes. And look at that, it worked. So we now have the temperature in Celsius for New York City, so 7.84 for New York City, and we know that they also have overcast clouds, just like Toronto. All right, so now we know that the dynamic part of this application works. Dynamic meaning that the user can then supply a dash dash city argument and then provide whatever city that they're curious about and then get the weather data back. So let's now refactor the code again and get rid of some of this debug information. So I'm going to get rid of the response JSON, and instead of printing the temperature is, let's print a more useful message. So let's say print the current weather in, and we'll pass in the name of the city. So the args.city, and because we've interpolated a string, we'll need to use f strings. So the current weather in city is, then we have the value back, which is temp, degrees Celsius. So now we have the current weather in your city is temp degrees Celsius. So that seems like a more user-friendly response rather than temperature is colon and then the data back. So let's try this out. I'm going to rerun the code. I'm going to clear the screen first and rerun the code. And we get this really nice formatted text back. The current weather in New York, US is 7.84 degrees Celsius. And so there we have it. We have accomplished what we set out to do, which is build a program that accepts user data. So the user provides the name of his city. We then said that we would grab the weather data for that city, and then we would present the weather data back to the user. And we did that with just Python inside a virtual environment using the requests third-party library inside of Notepad++. And we used the api.openweathermap.org service, and we got the data that we wanted back. Now we can also improve this code a whole lot more by doing some additional refactoring. We could move some of this logic into its own function, and then that would ensure that if we had another project that wanted to utilize the same logic, that they would be able to import it. So there's things that we can do to improve this. We can extend the functionality to then also accept additional arguments. Like instead of only just a city argument, we could also pass in perhaps the metric. So users could get data back in either Celsius or Fahrenheit or both. We could also make it easier for the user to pass in a city name without having to pass in a full string like Toronto, Ontario, CA. So we could infer what the state or country is based on the city name, or perhaps even provide the user with options. So the user could pick from, let's say, like the top 3 options if there wasn't a definitive city to infer. We could then add unit tests to help future-proof our code and make sure that future refactoring won't break existing functionality. So there's a whole lot of stuff that we can do, and I want to cover all this in more detail in future videos. But for this initial project, I think we have accomplished what we set out to do. And I welcome you to modify what we've created to work for your own use cases, and let me know if you have any questions or comments. But that's all I have for now, and thank you for watching.